Okay, in this tutorial we're going to talk about how to condense a logarithm. So we're going to be going in the opposite direction of expanding. So we're going to turn multiple logs into a single log. In particular, let's take a look at this example. Log base a of x plus log base a of y minus log base a of m. So what I'm going to do is I'm going to use these two properties that I've listed here to take this and turn this into a single logarithm. And what I want to do is I want to focus on two things. I want to focus on the fact that the first two logs are being added and the last one is being subtracted. So if I use those properties, I know that if two logs are being added, I'm going to multiply when I am condensing. So let's start with the first part. I'm going to take these two, log base a of x and log base a of y, and I'm going to turn that into log base a of xy. I'm going to leave the other part alone, log base a of m. Now what I'm going to do is I'm going to say, all right, well, these two logs are being subtracted. So when I'm subtracting logs, I'm going to have to use the second property where I'm going to turn it into a quotient when I'm condensing. So what I'm going to end up with is log base a of xy divided by m. And that's it. I'm done. So I've turned this example where I have three logs into a single log, and that's called condensing. It's going to be really important when we get into solving logarithmic equations. Now let's take a look at a slightly more difficult problem. I'm going to use the same concepts, but again it looks a little bit more complicated. The first thing I'm going to do is I'm going to take my coefficients and I'm going to move them up. So in other words, I'm going to take this 2, I'm going to move it up here and put it as a power. Similar situation here. I'm going to take the 1/2 and I'm going to put it up top. So anytime we have coefficients and we're condensing a log, we want to take those and put them up as powers. So what that's going to give me is log base b of 2y plus 5 squared minus log base b of the square root of x plus 3. And I'll explain why I did that in just a minute. Okay, when we have a 1/2 power, some teachers are going to be fine if you leave it as a 1/2 power, but for the most part, we would prefer anytime we have a 1/2 power to use a radical instead. Just keep in mind, in case you're looking at that and wondering, well, what does that even mean? Just keep in mind, x to the 1/2 is equivalent to the square root of x. So you should have learned that in Algebra 2, where x to the 1/2 is the same as the square root of x. So I haven't changed the problem at all, but I've made it a slightly cleaner form by using a radical. Okay, now what I'm going to do is I'm going to use my properties of logs to take this, and remember, it's a difference here. I'm subtracting. So I'm going to take these two logs, and since they're a difference, I'm going to turn it into a quotient when I'm condensing. So I'm going to end up with log base b of 2y plus 5 squared over the square root of x plus 3. And always make sure you put a big set of parentheses around the whole thing. And that is it. That is my condensed form of the original. Remember, a condensed form, you can only have a single log. You should never have more than one